Hi there, this is session 27 of programming from the very basics using Python. In the previous session, I explained how to define a function, and I also told you how functions are treated as objects, and I just started with the function arguments and how do you pass function arguments. We'll continue in this session where we'll talk about all the different syntaxes that Python supports in managing function definitions with different kinds of arguments that you can accept. So let's get started. So if you remember the last class or the last session rather, I would have told you that you can define a function where I created a function called greet and I represented a parameter or an argument called name, which is a positional argument, and I can print a function. I can print a message by just typing hello followed by the name. We can now call this function greet. If you don't pass an argument, it throws an error. We all know that. We learned that in the last session, that function prototypes in this case are quite strict. It is requiring an argument, like you see here, and you need to pass an argument that is name. Now, when you want to call a function, you can also call a function passing argument positionally this way by default, but you can also pass an argument as a keyword argument in case you want to be more specific on what name must be equal to. So when you call a function this way, it's represented as calling a function with keyword arguments, as you can see here. If you have a function that just takes one argument or maybe one or two arguments, it may not make much of a difference. This just makes it more specific, but is there any benefit to it? The benefit comes up when you have function with multiple arguments. Let me show you another example where, let's say, I define a function that now takes more arguments. Let's say name and place at this moment. Just take two arguments for now. And I just want to greet a user to a place. So I'll just type hello name. I'm using the format literal string syntax. So I guess you know this by now. If you have to skip my earlier sessions, you can go back and look into a session where I talk about strings. And there I cover more about this format specifiers that you can use in the format literal string syntax. So I type hello name, welcome to place. This time, when I call a function, I need to pass two arguments in here, but I can just use greet of, I can type something like John, and maybe a place, let's say Denver. This is calling a function by passing positional arguments. You're passing arguments by position. I'm trying to say the first argument must be John. I don't know what the argument name is. First argument must be John. Second argument must be Denver, right? So I'm just passing by value here. So when the function is being invoked, it calls a function by setting name equal to the first argument and place equal to whatever you pass as a second argument. That's how you can see the message, hello John, welcome to Denver. This is how positional arguments are assigned to the positional argument variables that are there in the function definition and are invoked. You could assume that this function is invoked by using tuple, it's a parallel assignment. Let's say in this case, name comma place equals John comma Denver here. Assuming that you call a function with these two parameters, these two arguments, you can assume it's like a parallel assignment being done to these argument variables, and then the function body is invoked. But however, if at all I want to somehow tell Python that the first argument that I want to pass is place and second argument is Denver, can I do it like this? Can I just type Denver and then John? Well, the Python syntax grammar will not complain because the function expects two arguments and you're passing two arguments. There's no any checks for types in my function body. So this will still work, just that it is syntactically correct, but semantically this is wrong. Like you can't say hello Denver, welcome to John. You're assuming that John is a place and Denver is a name. Not really the case, right? Now let's assume that I want to treat Denver as a place and John as a name, irrespective of in what order I pass these arguments. This is where using keyword arguments makes sense. I'm just going to call this function one more time. This time, I'm just going to type place is equal to Denver and name is equal to John. This is the benefit. When you have a function that takes about, let's say, 5 or 6 arguments, there could be functions that elaborate. They take 5 or 6 arguments. Remembering the arguments by position can be a little difficult. You need to always keep that function prototype in one place, in maybe another screen, another window, see the function prototype, and then you need to know how to match up those arguments. But it's not always very easy, but it's very easy for us to remember names like, words rather than numbers and position. We human beings, right? We don't remember phone numbers, but we remember names, for example, for all our friends and family, let's say. So if I'm going to call greet, I know that greet takes 2 parameters by the name called name and place. I know them, but I don't know in what order should I pass them. In such cases, calling a function with keyword arguments makes perfect sense, where the order does not matter as long as you match up the keyword argument with the actual argument name that is there here. Of course, some of you might ask, what if I call greet with some argument that is non-existent? Let's say city is equal to Mumbai, for example, and name is equal to Tim. And now we can see that it throws an error, and the error is a runtime error because it'll know that greet does not take an argument called city only by runtime. Syntax grammar looks fine, but in runtime it says type error in this line, right? You can see the type error. Greet got an unexpected keyword argument city. Just know this. So you pass a keyword argument that does where this keyword which you pass here does not match any parameter names here, then this is the error that you would expect. Now I can also create a function where I can make the place a default. This time I made the place default. This is called as a default argument. This act of setting a value in the function definition is called as a default argument. But this time I can call a function by a variety of ways. I can just call greet of John. When I say greet of John, I just pass one argument here. Though this function is defined to take 2 arguments, but one of the argument is not mandatory. It's not compulsory. That's optional, right? So if you don't pass that argument when you're calling a function, it assumes the default value for place is going to be Seattle. But however, if at all I call the same function greet, and this time I pass John and let's say Sydney, and now we can see that Sydney is going to replace the default argument for place. So place becomes Sydney and no longer Seattle. And this is the behavior. So when you pass an argument, it's going to substitute or not substitute, replace the default argument. But if you don't pass an argument like I did above here in this particular statement, the place is assume the default of Seattle and it continues. So this is one of the syntax that is supported. And yes, when you have a positional argument, which is a non-default argument, followed by a default argument, when you're defining a function, these rules apply, and that is, I can't say maybe name is equal to guest and make place a non-default argument. If you define a function like this, you can see that VS Code sort of highlighted it. It says there's a problem, but if you run this now, you get this error. The error you will see is, you can see it's a syntax error, non-default argument follows default argument. And this is one important syntax rule that you should know about when you're defining functions. So when you define functions with multiple arguments as a part of function definition, you have to make sure that all the non-default arguments come first, then followed by default arguments, not the other way around. And this is an error, right? It's no way to fix it. So there's also another rule. Let's assume that both name and place are set as default here. Both name and place are now set default. Let's say the place, I'm just going to take it as maybe Chennai, the place where I stay. Now, this function is quite flexible. You can call this function with one argument. No arguments, that is, no arguments. You can see what really happened here. When I call greet this time, you can see that because it did not pass any argument, name was assumed with the default arguments. So name is equal to guest here. And place is also taken in as a default argument that is provided in the definition. That's Chennai. So place also becomes Chennai. But however, if at all I try greet of Smith, for example, because I passed a positional argument here, this is going to replace the first parameter, whether it's a default or non-default argument. It matches the first positional argument with the first parameter that's there here. So if you run this, as you can see, it calls hello Smith, but place is the default, which is Chennai. If you try to call greet of, let's say, maybe, Jane and Mumbai, for example, you can see it actually applies Jane for name and applies Mumbai for place. So name becomes Jane and place becomes Mumbai, and you can see the default arguments are no longer there. They are all being replaced with the parameters or arguments you passed on here. And you can see this is what you see the result. It says hello Jane, welcome to Mumbai. But what if you do this? What if I try greet of place is equal to, let's say, New York, and name is equal to Charles? It still works because place and name are the actual names of these arguments that in the definition. As long as they match when you make a call here, this works without a problem. But what if you do this? Greet of, if at all I try maybe place is equal to Delhi, and I pass an argument position, let's assume Damien. Now this is a problem. The third invocation would be a problem. Try running it. It's a syntax error. You can see it's a syntax error. Let me do one thing. Let me just cut this cell across so I can see this separately. This so far works, right? But I'm just going to call greet of place is equal to Delhi and then followed by an argument like this. This will be a little misleading or confusing to Python. I would say it's rather a limitation of the Python syntax grammar here, because I know some language like Ruby that lets you even do this. They figure out smartly how to apply Damien to name because place is taken in. If you try a language like Ruby, this would work. But in Python, this is an error and it's a syntax error. The rule is, even when you're making a function call, keyword arguments must follow positional arguments. The syntax error says positional argument follows keyword argument, and that is not allowed. So when I'm making a function call, keyword arguments must follow positional arguments. You need to have all the positional arguments first, followed by keyword arguments. So this is an important grammar rule or syntax rule that you should know when it comes to invoking functions, right? So you have to make note of this. So you should also note, even when I'm defining a function, you cannot have a non-default argument here that comes after a default argument. That was an error, right? This is in the function definition. Even when I'm making a function call, a similar rule applies. You cannot have a keyword arguments being passed before positional arguments, right? So this is something that you should know. Now, having told you about this basic rules of syntax and how you can create functions with default arguments and positional arguments, there are times where you want to create a function that can take variable number of positional arguments. And how do you create such a function? Let's say I want to create a function where I want to greet multiple users. So such that if I just leave it as pass for now. If I should be able to call a greet like this, it should work. Maybe it prints nothing, but if I say greet of John, Alice, Tim, Bill or Dave. Or if it's called greet of just Lisa, Emily, Sarah, it has to work. Now here's an use case where I want to call a function with variable number of arguments, which I'm passing positionally. I should be able to call greet with no arguments, greet with 4 arguments, greet with 2 arguments, with 5 arguments. It should work. If you want to create a function that's fully variadic, the way you do that is within greet function, right? The function definition, you add an asterisk here. You add an asterisk followed by any name here. I'm calling it users. The act of putting an asterisk before a parameter, oh, those of you who come from C or C++ will just look at this and say, it's a pointer. No, nothing to do with it. There's just a Python syntax, nothing related to pointers in C, where also use asterisks, but that's something else, right? What this effectively does is, sometimes people call this as splat args, the Ruby world, right? They call them splat arguments. So Ruby, Groovy, they use that term. But what it means is that when you use asterisk followed by users or star users, I would call it, this works like tuple packing, which means it tries to assume users is equal to whatever you pass. Like say, maybe I don't have to use parentheses here. So users equal to John, Alice, Tim, and Bill, and so on. When you perform an assignment like this, you know what happens. All of these get boxed into a tuple, and the tuple is passed as a parameter. Now you should note that while I'm calling a function, I'm not passing any tuple here. I'm just passing comma separated values, comma separated arguments. And these arguments are boxed into a tuple and assigned to users. If at all you put an asterisk for users. So you can just try here. I'm just going to print users as is and put type of users here. So you know exactly what type it is. The first time when I call greet with no arguments, it's an empty tuple. The next time you can see it's a tuple with all the parameters being stored in, and it shows class tuple there. Some of you might be a little confused and say, what if I don't have this asterisk here? Will that not work? Well, it causes a problem. When I try something like this, what really happens is John gets assigned to users, but all these are extra parameters that you're passing, are extra arguments you're passing positionally, for which there are no variables defined. So when you run it like this, it will throw an error. You get this typical error that says greet missing required positional argument users for the first time. You need this argument. Even if you sort of remove this, or if you add just some dummy argument here, James, for example, you can see still greet takes 1 positional argument, but 5 were given. It executed with this use case, right? Because I passed just 1 argument. But if I pass more than 1 argument, it throws an error. So in case you want to take in multiple positional arguments passed on to a function, when you're calling a function, into a single tuple, then you just need to use this syntax. And this would work. This is how you can create a variable arguments function or variability function. Some people, there are different terms used in different languages. I've seen for this kind of a function definition, they call them as varargs. That's a very common term used amongst various languages. Varargs is like variable arguments, right? So you can call this as varargs. That's a very common term that I am comfortable with. But when I looked up the Python tutorial, it's a mouthful. It says they call this as arbitrary argument list. Wow. Arbitrary argument list. Or sometimes in some other languages, they call them as variable arity functions. Function that can take variable parameters or arguments. It's all the same. No matter what term you use, it means the same thing. So this is how you can get a function with some flexibility, and you can mix them along with other kinds of arguments. For example, you could do this. Okay. Just one moment. Yeah. Let me edit this off. let's say that, okay, I don't need this. Control K doesn't work. Okay. I can just type maybe, this time I'll type user and age and place, and I'll say star visited or visits. All I'm going to do is just print all these variables in here in place. I'm just going to use, maybe I'll just remove age from here. It doesn't matter. Just want to keep it simple. Let's say user, place, and visits. This time I'm just going to print the value of user. Print the value for place and print the value for visits. Now, if I call greet with no parameters, will it work? Will it? Well, as you can see, these two arguments are non-default arguments, so they are compulsory. You need to pass them. You just can't call greet with no arguments. It's going to fail with an error. The minimum number of arguments that you need to pass are two arguments. It says greet missing two required positional arguments, user and place. So I call it like this. Here, say greet of, I could just type maybe Sam and followed by some place. Let's call Delhi. It works. The name and the user and place is compulsory. Now visits doesn't take anything. No extra arguments are passed. So visits is an empty tuple. But if you pass some more arguments, let's say, I hope I spell it right, San Diego, and maybe let's say Melbourne, and Berkeley. And you can see what really happened here. You can see that Sam was assigned for user. So user is equal to Sam, place is equal to Delhi, and visits is equal to all of these in a tuple. And that's how you see it here, right? In the very early versions of Python, and I say very early, I think it's before Python 3.4, if I'm not wrong, or was it 3.3? All these versions, the very early versions of Python. Before Python 3.4, I can guarantee you that. There is a limit or there is a restriction on how you can use this star args. We also call them star args. That's a very common word used in many places. The star visits, in this case, there's a restriction. After the star args, you cannot have any other kind of default or non-default argument. It used to throw up as a syntax error. Maybe I can try showing you if I have Python 2. Yeah, I do have Python 2. Let me try to define a function. Let's call this function. I'll do one thing. I'll just paste this. Let me copy this code. Unfortunately, in Python 2, you don't have the format literal string syntax. I'm just going to type user, place, and visits. So call greet. Oh, in this case, it works, right? You can just see John. And I can just type Delhi. And maybe I'll just type maybe Pune, Chennai, Mumbai, all the different cities in India. And so far, so good. It works. But if I define the function differently, where I put visits first and followed by place. Now try running it. It right away throws a syntax error. You can see this right here. It shows the invalid syntax. This was a limitation on all versions of Python before Python 3.4. I need to check whether it's Python 3.4 or 3.3. We can just look up the change logs in Python documentation, but I will tell you older versions of Python. If you get a syntax error for something like this, you are using a very old version of Python. And as you can see here, I'm using a very ancient version of Python. It's Python 2.7, though it's a last release and maintained in year 2022. I'm not sure if they're doing still development on it. I'm not sure. I heard that in 2020, this is marked as end of life, but it looks like some patches were applied. Maybe. Oh, it was build time, I guess. It's not the release date, but it's a build time. It was built during this date. That's what it is. All right. So it's an unmaintained version now. There's no reason for you should use very old versions of Python anymore until unless you're maintaining some old, very old legacy code in large corporations or organizations. But in such versions of Python, you have this issue. But here I'm using Python 3.11, so which is pretty recent. So this does not have a problem with having place like this. But when you call it, there's a small restriction. Just see what happens. Think about it. Sam is assigned user. So user is equal to Sam. User is equal to Sam. But after that, when you put an asterisk visits here, you know what happens? It takes rest of these positional arguments into visits. Visits will be all of these positional arguments. But what about place? There's an ambiguity. So if you try running it, you get this runtime error. And you see the runtime error, it's very specific. It says, greet missing one required keyword only argument, place. What this really means is, you cannot pass a value for place by passing them like this, by position. It wouldn't work. If not, you want to make the place as, let's say, Berkeley here, you need to actually pass them as a keyword argument and you don't have a choice. It's compulsory. So if you want to make any keyword arguments compulsory, that means you have to call the function only by passing keyword arguments, not as position. Then you can put an asterisk arg any form and followed by this. And then you need to pass it as places equal to Berkeley. If you just tried Berkeley, it didn't work because of the moment it says star visits here, it's going to take up everything from this place till the end. All the positional arguments are collected into the tuple. But this is not a positional argument that you're passing. It's a non-keyword argument. It's a non-keyword argument here. So, sorry, it's a mistake. It's a keyword argument here, right? It's not a positional argument. It's a keyword argument. So therefore, this will apply to place. This will not be taken into the tuple called visits. Do note this. This is a useful feature. Taking cues from here, they introduce an interesting syntax in Python that you will find in a lot of places, in many functions. If you deal with frameworks or many functions in the standard library, for example, where they say that maybe if I have a function called greet and let's say user, and I put an asterisk here and then put a place here. You know what this really means? I'll tell you what it means. It's a print. I'm just going to print user equals and place equals. If I try to invoke greet and pass John, will it work? Nope, it doesn't. But can I? Okay, so I'll try to put John and maybe, any place. Let's say Silicon Valley. And still it doesn't work. It still doesn't work, as you can see here. So there are just two arguments with names here, which is user and place. I'm passing them, but it still doesn't work. The reason is because the moment you put a blank asterisk here, any arguments followed by that can only be passed on as a keyword argument, which means that you have to pass Silicon Valley as place equals. There's no other rule. You're sort of forcing your user who is going to use your function. Let's say you define a function and you expect users to use your function. To make it easy to maintain sometimes, you might want to say, oh, this particular argument, don't pass it as position, pass it as keyword argument. I will tell you the more realistic use case for it. Let's say, let me create a dummy function. Okay, let me create a dummy function for that. Let's say that I want to create a function called connect. Maybe that connects to a database, let's say. It doesn't really do it. It's a dummy function. So it's just, I'm trying to show the template or the skeletal syntax. Maybe I want to connect to a host, port, which are compulsory, but assume I'll make the port as a default, let's say 5217 or something, which is a default argument. And then I want to pass all the configuration. or maybe not configuration. Just leave an asterisk here, and or maybe I'll not have an asterisk. I'll just provide maybe I'll just use something called keep alive equals false. Let's make this default argument. And now when I try to print, I'm just going to print host. Let's say maybe host equals port equals and keep alive equals. So when you actually try to call connect technically requires just one argument to be passed, mandatory, right? The other arguments are not compulsory. You don't have to pass them because they're all default arguments. So when I say connect off, I provide some host. Maybe I'll type localhost. It works. But maybe I could call connect like this. I could just type connect of localhost, pass a different port number. Maybe I can just type maybe 67798, some arbitrary port number. Let's assume the port was 5217. That's the default. I'm changing that. And then I pass something called true here. Now, when you actually call a function like this may not be very intuitive, especially the last one. What does true mean? True for what? We don't know. We don't really know it, right? So one of the ways I can make it more explicit to the user is make it add an asterisk here. The moment I add an asterisk here, and when I try to call this function now, you can see that it throws an error. It says that connect takes 1 to 2 positional arguments, but 3 were given. So you cannot pass more than 2 arguments positionally, because after an asterisk, everything that you need to pass must be a keyword argument. So you have to explicitly say keep alive equals true. But don't worry about what that keep alive means and what port and host means. It's just a dummy thing, right? It's mostly, you will see certain frameworks use patterns like these. Just trying to sort of reproduce that. So that means that I have to pass keep alive only as keyword arguments. But of course, that argument is not compulsory also. If you don't pass it, the default, if you don't pass this argument, it works. So if you don't pass this keep alive argument, it works. It's assuming false. But if you really want to pass it, you have to pass it only as a keyword argument. Maybe having numbers like this, it doesn't make sense. I don't know what that is. What's that number? It's a port, max connections. What it is, I don't know. Or max users, we don't know that. So what I can do is, I can actually make this asterisk all the way here to sort of force your user to indicate what is that number, right? So when I'm calling it, so I can actually, when you put it this way, it'll fail for both of these versions. You need to pass port is equal to. You also need to pass port is equal to. But you get a lot of flexibility here, a lot of flexibility where you can actually the default port and only pass keep alive. Just look at this. But remember, all these I'm typing on the video, which you're obviously watching. Unless you type it and play around, try out all the permutations, you will not learn. I keep reiterating that. So try all these things out. Try creating a function. Maybe create a function with an argument. Let's say host is equal to some default, right, argument. And then maybe try all these permutations and see how it works, right? That's how you know it. But you should know what is the role of having simply an asterisk here. That's what this means. There are many places where you'll actually see things like these. Is there a built-in function? I don't know, but yeah, there's one place I can think of is when you try to say from threading, import thread. Thread is a class, but then you would look at the prototype of it. You see this. Let me tell you, when you're calling a class, it is no different than calling a function. The arguments that you pass on to it has the same rule like passing function arguments. It's a call operator. The parenthesis is an operator called as a call operator. It's a syntax grammar for that, right? So here is a thread class signature which says group is equal to none, target is equal to none, name is equal to none, args is equal to none, keyword args is equal to none. But there's an asterisk here, if you observe, followed by daemon is equal to none, which means you can create thread like this, right? No argument. You can type thread of name is equal to test thread. Oh, am I teaching you multi-threading here? No, not really. Actually, this creates a thread, which must be read out at some point. Okay. Hopefully, after the session, I will kill this and respawn it. You can see that I passed name, and the name is shown there when you try to get the string representation. The name is shown up as test thread there. So I can't, can I call it with test thread like this? This might cause a problem. It shows an attribute error. See, the problem is there are multiple default arguments. If you pass them positionally, the first parameter for thread is supposed to be group, which must be equal to none. Can't be anything else. That's a rule in multi-threading, legacy features. You can see that it throws an error here. It shows group argument must be none for now, right? So if you want to call it, you have to call it like this. You have to say none. Followed by, you can say test thread. It's going to fail with an error because the second argument is supposed to be the target. It somehow created a thread, but see, it's not name. It's assumed as target. To say the name of the thread must be test thread and not called thread 5, I'd say name is equal to cherry picking it. So sometimes you have functions or classes that take multiple parameters and all of them are set as default arguments. But you can cherry pick and say, oh, this argument I want to change. I want to change only name. I want to change only target. I want to change only args or keyword args or something like that. So that flexibility is there in thread class. But the last parameter, daemon is equal to, can only be passed as a keyword argument. You cannot say true like this. It's not going to work. Right? Okay, assuming that you call with test thread like this. Actually, you know what? True became the name because by position, right? If you look at the thread class constructor, first argument is group, second argument is target, third argument is name. So if all I want to skip all these arguments and set default argument for, I want to set daemon, I cannot just pass as true or false. I have to say daemon is equal to. It is the only valid way to set this argument. See, it's now it shows initial daemon. So these are things you should know about how you can call functions with arguments by position, default arguments, and calling function with keyword arguments, defining function with default arguments and calling functions with keyword arguments. And I told you about what is the role of the star args, the star arguments, or warags if you want to call that. And what happens when you define a function with only an asterisk in it? Everything after that is treated, should be called with keyword arguments being passed. That's what this means. These syntax grammars are quite recent. In fact, I'm not even sure if it's there in very old versions of Python. Maybe it was introduced in Python 3.4 or 3.6, these versions. We need to verify that, right? So all of these are evolving changes in the Python syntax grammar, right, in the last 10 years, I would say. Let me just get rid of thread class here. Now, I told you how you can call functions, and remember, thread is a class, but whatever rules I told you for function, passing function arguments, or even defining functions, they're applicable to even class definitions and, the way you invoke a class. When you invoke a class, you're basically constructing a class, the constructor expression, I would say rather. They take in the same kind of syntax rules like function call. Now that I told you about couple of arguments. I told you about positional arguments and keyword arguments and defining function with default and non-default arguments, and I told you about star args. The next feature I should talk about is defining a function like this. This time I'm just going to let's call it testfn. Say it's a test function. So let me just use some dummy variables for now. Keep it simple. I would say a, comma b, and I'll just type, let's say, star C. The moment I do this, you can say print A and B and C is equal to, and sorry, I put this F inside, it should be outside. Yep. We try to call test Fn. How many arguments are compulsory? A and B. We pass 10 and 20. Everything after that is accumulated into C. But what if I want to create a function that takes arbitrary keyword arguments? It can be anything. Let's say I want to create a function where I should be able to say, I should be able to call a function like this, where I say test Fn of x is equal to 100, y is equal to 200. And I can say s is equal to 5.6. Now, as you can see here, the parameter names that I'm using here, the keyword arguments, right? X, y, and s is not in the function definitions prototype. What happens when you call it? It will throw an error, obviously. It shows test Fn got unexpected keyword argument x. Right? Now, if I define a function a little differently, okay, I'm just going to copy the cell. And I only use star star double asterisk. And I'll just type maybe anything. I'll just say data for now. And I'll print this data equals to show you what it is. First, let me call it with the second format. It works. Now, when you define a function with double asterisk followed by a name, which will be the variable name, what really happens is that all these keyword arguments that you pass, they are accumulated into a dictionary. It's like trying to say that this function is called after doing this. It's like telling data is equal to, create a new dictionary of x is equal to 100, y is equal to 200, and s is equal to 5.6. It first creates a dictionary and then invokes a function body. So the keys become the keys in the keyword, right? Become the keys of a dictionary, and the argument that you pass like 100, 200, they become the values. You can see that over here. So this takes in as a dictionary. Remember, single asterisk, you get a tuple. Double asterisk, you get a dictionary. No, you don't get a list, by the way, or a set or anything else. It's either a tuple or a dictionary. Star args and star star KW args, or quags they call them, right? So you can see this out. If you try to call this function, however, by using test Fn of 10, 20, 30, this is not going to work. This will raise an exception. You can see it says test Fn takes 0 positional arguments, but 3 were given. So this particular function does not take any positional argument. It only accepts keyword argument into data, because it doesn't make sense. If I say 10, 20, 30, you cannot store that in data by any means, because there's no key associated with it. You only have values, right? So when you define a function only with this kind of a syntax or this kind of signature, then you can only pass keyword arguments to it. But you can pass any keyword argument. You can type user is equal to John, and you can just say maybe, test data is equal to, or you can just say quads is equal to 4.5, 6.7 or something. Or this works. The first one worked, which you can see here. The second one, because I'm passing positional arguments, they are not compatible with this kind of a function prototype. Now, if you want to create a function that is completely flexible in what arguments it can accept or take, right? You can define a function like this. And you'll see this kind of naming convention used very commonly in a lot of Python code, which will be like star args, star star, quarks they call, or KW args, or keyword arguments, or whatever you want to call it. It's just a name. It's like you have args and quarks, we call it, right? So when you define a function this way, I'm just going to print what the value of args is and the value of quarks is equal to. Now this is quite flexible. For the first time, I just call this function with only keyword arguments and nothing more. I mean, I did not use any positional arguments in here. So all of these are collected into this dictionary, and the args being a tuple is empty. So args represents tuple of all the positional arguments. Quarks happens to be a dictionary that accepts all the keyword arguments. Remember, these args and quarks are just commonly used naming convention in a lot of Python code. It doesn't mean that this is what you should use. You can give any name you want. You can call it star X, star Y. Works perfectly fine, right? So these are just commonly used names in Python. Now you can call this function in myriads of ways. Second time when I call the function only by passing positional arguments, you can see that args has got all of those positional arguments and quarks is empty. But if at all I try testfn of 10, 20, c is equal to 50, and then say x is equal to 78, or say y is equal to some number 12, I can see what happens. This is a very flexible function, and you can also call this function with no arguments in here. Both the tuple and the dictionary is empty in this case. Sometimes you create wrapper functions. This happens when you're building slightly larger frameworks. You're creating a function that will act as wrapper to different types of other functions. The other functions that you want to call through the wrapper, they might take one argument, they might take 2 arguments, or they may take multiple keyword arguments. The prototypes can change. But you want to create a generic wrapper function whereby whatever arguments you pass on to the wrapper must be faithfully passed on to these functions, matching this function's prototype, right? For such kind of wrapper functions, you normally use this kind of a signature. A function that can take any number of positional arguments and any number of keyword arguments. Positional arguments are accumulated or collected into a tuple, and all the quarks or keyword arguments are accumulated into a dictionary, represented as quarks here. So this is what you should know about functions and function prototypes mainly. So this pretty much summarizes how you can create a function with compulsory positional arguments, also called as mandatory arguments or non-default arguments per se. Let's say greet of name comma place, for example. If it's a greet of name comma place is equal to Mumbai, that place is equal to Mumbai becomes a default argument in the function definition. You can have multiple default arguments, right? And the rule is you cannot, when you're defining a function, your default argument should come after non-default arguments. The converse of it, when you're invoking a function, when you're calling a function, you can call a function by passing arguments as positional arguments to say first argument value, second argument value, third argument value, and so on. But you can also call a function passing keyword arguments, where you could say call a function with a is equal to 100 or b is equal to 500 and so on, and they should match the prototype of the function. The names should match. And I told you how you can take variable number of arguments in a function by defining them with star args here. Variable number of positional arguments. If you want to take arbitrary keyword arguments, then you define a function with star quarks, right? Now, when it comes to calling a function, you can call a function passing a value positionally, or maybe you can pass them as keyword arguments, assuming it matches with the function prototype. Now, consider a use case where I have a function that takes, let's say, 3 arguments. Let's say I have a function. Let's call this as connect of host, port, and user password. Let's say 4 arguments. And here I'm going to just print a message, just a dummy message. You can say connecting to, mistake. Connecting to host equals, port equals, as user equals, with password equals. I'm just putting up all these arguments are going to be printed in here. Now to invoke this function, you know that all these arguments are compulsory, right? It's non-default there. So when you want to call the function, I'd say connect of, let's assume localhost 8080. Let's put some, okay, yeah, I just actually hit the enter key and control enter, and it threw an error. See, it doesn't, number of arguments not sufficient. So I'll just type username as, I'll just say John and password as secret. The function requires 4 arguments as per the prototype. I'm passing 4 arguments here. Nothing new. We all learned that. Now, let us assume that these 4 arguments that I want to pass to a function is already stored in a tuple or a list. In this case, I'll just use a tuple. I'll just say maybe info is equal to, let me copy this. This way. Now, info is a tuple, as you can very well verify. I just get a tuple called info. It's a tuple, right? It's a class tuple. I want to pass each of these items of this tuple as arguments to connect, individual arguments to connect. How do I do that? Can I not call connect of info? Shouldn't that work? That's a problem. When you call connect of info, you're passing the tuple for the first argument, that's host. So host is equal to info. Host is equal to info. Now there's a problem because Python on its own does not know that, oh, info has got 4 items. I need to make sure that first item should go as host, second item as port, third item as user, and fourth item as password. It does not do that. The syntax grammar try to check that, okay, when I'm calling this function, that is, it's trying to check that, okay, I'm passing an argument info, it goes to host. The entire tuple is sent as host. Now, because of this, you get this error. It says connect missing 3 required positional arguments, port, user, and password. Many times, you have a function that take many arguments, and you want to pass each argument to the function by unpacking a tuple or maybe a list or any iterable object. Let me tell you, any iterable object, as long as the length matches. The iterable object should just have a length of 4 for a function that takes 4 arguments. You want to make sure that each item of the iterable is sent as individual argument to that function. So some of you might look at this and wonder, this is difficult. The one painful way to do that is, I've seen some production code 10, 15 years back, 15 years ago, when somebody did this in one of the code bases, which requires connecting to some backend services, which that a function that connects to services actually had like 6 parameters, and 6 parameters are painfully passed on like config of 0, config of 1, config of 2, config of 3. Yeah, like you here, I call this info here. In that place, it was known as config. This works, no doubt. And now this looks painful, isn't it? Yeah, write all these things, info of 0, info of 1, info of 2, info of 3, and then wonder, isn't there some kind of a loop that can let you iterate over info and take each item and pass them as individual arguments to function? You might think of that. Have some kind of a loop which has take each item and pass it as function. Well, the good news is you don't have to do that. In Python, in all the versions I've seen, modern versions that is, you can directly say connect of asterisk info. The moment you add an asterisk before a variable, this variable that you pass on here must be an iterable object, must represent an iterable object. So info represents an iterable object, which is tuple in this case. It can be a list, it can be a set if it makes sense, as long as set is unordered. So that's one big problem. So assuming that all the items are like identical stuff, then maybe a set also will do. So any iterable object will do, but the length of it must be a length. It must have a length. It should give me 4 items, not more, not less. And then this works. If the tuple had another parameter, let's say I'm going to use something like false here, it'll fail. Connect requires 4 positional arguments of 5 are given. So it just passed all these 5 parameters when you unpacked it in here. And false was also passed, but the function does not take more than 4 arguments. And that's why this error came up. So you need to make sure that the size matches. If you're passing a tuple or a list especially, you get the same output, same outcome. Just carefully observe. In the function definition, when I use star args, it does the opposite. What does it do? It collects multiple arguments passed on to a function, boxes it into a tuple. Whereas this does tuple unpacking for you. When you actually call it like this, maybe I'll just make a separate cell and I will tell you what really happens and remove all these other calls over here. When you call connect of info, star info like this, the connect function body is invoked after performing this. It's like typing host, port, user, password equals info. We're going to learn this as tuple unpacking, didn't we? In assignments. In the session where I talked about assignments, all about assignments, I think I talked about tuple packing, tuple unpacking, parallel assignment, this tuple unpacking for you. It unpacks a tuple into these parametric variables or argument variables that is there, and then it invokes the function body. Right? That's what you should know. It's also possible that I have this info, but not in the right order. Maybe I have John first, which is not really the host. I have John first like this. And then I have localhost and then I have, let's say, secret, which is supposed to be the password and 88. If you still try calling it, it'll work, but the whole thing gets messed up. Host is equal to John, port is equal to localhost, user is equal to secret. Not semantically correct, right? Now, if you believe that the arguments to a function that you're going to pass, the order you don't remember, but you know the names, you know those names, but you're not clear about the order, then what you could do is you could make info as a dictionary. I'll just create a dictionary literally like this. And in this dictionary, I'll type user, John, host, localhost, password, secret, and port 88. What I've done here is that I've constructed a dictionary, and the dictionary's got keys, and the names of these keys match the parameter names, but may not be in the same order. You can see that user is third parameter, but I have them as the first item in the dictionary. Host is first parameter, but that's the second item. Password is the last parameter, the fourth parameter, but you can see it's the third item. So it goes on. The order doesn't matter. The order doesn't matter. The order can be anything, but you can see that these keywords match the keys of a dictionary. I think I forgot the quotes here, I guess. Yeah. So if you're going to be passing a dictionary to connect, you can't use star info. When you use star info, it's not going to throw an error. This is what will happen. Because when you iterate over a dictionary by default, you're going to be iterating over the keys. This time you can see that user, host, password, and port is passed as values. What you normally do, if you want to pass a dictionary, you want to unpack a dictionary and pass each key value pair, substituting as keyword arguments to connect, then you can use this way. The act of using double asterisk info here makes the call as, it's like connect of user is equal to John, host is equal to localhost, password is equal to secret, and port is equal to 88. It unpacks it into keyword arguments and then calls a function. So these are all the different interesting prototypes that you should know related to functions. But the last one, always I end up trying to finish, but somehow I remember, there's something I missed. Yes, there's one more feature. I think this feature was introduced in Python 3.7, if I'm not wrong. So it's a quite recent feature compared to others I talked about, other syntax grammars I talked about. So what is this all about? Let's say I have a function. Let's call it testfn for now. I just type a comma b followed by a forward slash. I put a forward slash, right? And I define a function like this. If I try to print, let's say maybe as usual, a is equal to and b is equal to here. Let me call testfn of 10, 20. No problem, it works. Now what's that forward slash about? You might ask me. Yeah. If you put a forward slash, anything that comes before the forward slash can only be passed as positional arguments, never as keyword arguments. That's a rule. So if you put a forward slash here, you can call it like this. But try calling it as a is equal to 10 and or maybe a. I'll just say maybe 10 comma b is equal to 20. Just set one of them as keyword arguments. This will throw an error. There are certain use cases by design where you want the user to invoke your function where you don't expect the user to pass the keyword arguments for your function because those keywords you're using, like testf and ab, tomorrow you might change it from ab to x comma y. So tomorrow, let's say you're writing a function, somebody's using your function. So if the user was calling it b is equal to 20 today, let's say tomorrow you change the function and say, no, I don't want to call it b, I want to call it like say y. That's a problem. Everyone who's calling your function will suffer because they used an older name. It no longer works. So you want to tell the user upfront, never call my function with keyword arguments for these because these are implementation details that I want to hide from you. So I don't expect you to call it as keyword arguments. Then you could actually use this technique. This will ensure that you can only call these functions with arguments passed positionally, not as keyword arguments. And finally, you can mix everything. All the concepts I covered so far. So if you're looking at a function that's completely full-blown with all the syntax nuances I covered so far, this is how we do it. You could actually type a function, define a function where say testfn of all the arguments that you want to pass only as positions, only by position. I can put a forward slash just to demarcate it. That means I can say everything before the forward slash are position only arguments. After that, I can put c comma d, which can be passed on either as positional arguments or as keyword arguments, followed by, I can just use e is equal to 10. This is a default argument, right? Then you can use an asterisk. An asterisk is a boundary after which whatever you pass, whatever arguments you have, must only be passed on as keyword arguments. So we can say f. There's a compulsory keyword argument, or you can have f here because you have e is equal to 10. This is called syntax error, right? Let's just keep it as this way. Okay, it's fine. I say f, and I can say g is equal to 10, right? This is also valid. And then I can use star args, and then say star keyword args. Actually, star args should not be mixed in here. It doesn't make sense. But I'm just trying to tell you, forget about star args and star keyword args. But this is how it is, right? So these are all position only arguments. These can be passed as position or keyword arguments. These can only be passed on as keyword arguments, never as position arguments. So that's how you see all of these working together. These are covered in great detail in Python tutorial. I should tell you this. Everything that I covered in this session, I recommend you also to go and read the Python tutorial. Maybe I would have missed certain things that's covered in the tutorial. Possibly, right? So you can check out the Python tutorial. I'll just open it up for you. I think I'll go to the Python documentation here. Go to docs.python.org. There's a website, the official documentation, and always point you to the tutorial and ask you to read it. And in this tutorial, there's a dedicated chapter number 4. I told you the most meatiest or the chapter has got a lot of stuff is this one. In this chapter, defining functions, what I covered in the previous session, but I think not everything that I covered is there here. There are certain things in it. So yeah, but most of the things which is there in the tutorial, I will be finishing when I'm wrapping it up tomorrow in the next session, right? So when you look at the 4.8, which is what I covered today, in this session. So you can see that more on defining functions. How do you create a function with default arguments? And as I always tell you, don't just read this code and just say, okay, ask okay prompt, return is equal to 4, remainder is equal to please try again, I know it. And while true, reply is input, okay, text user input. This is the most common habit of people. They just look at a program that's written here. It looks very, very readable. Say they read this code and they assume they know it. And then you close it, try running a code in Python, and they struggle. Where do we start it? Was there a function definition? Was that, oh, was that a keyword argument first? You don't know. So it's always a good practice to look at this code, try it out by looking at this code once, execute it in your Jupyter interface, in your IPython or Jupyter interface. Try it out, explore, try to refactor, try to make some alterations, try to make some changes and see what happens. And that's how you learn. That's how you learn, right? I keep reiterating that. We have come a long way now. We're almost in session 27, but I have to tell you this. As we started from the first session till now, you have seen me, the tone and the pace has changed a bit. So in the first session, I was very slow, very relaxed. I was telling you very basic stuff to get you started. But as we go along, I'm just cramming in a lot of code, running through a lot of cells in front of you. But that's what the learning is about. So you have to try all these things out. You have to look at that code, try it out, try to assimilate it, and get better at it. And that's how you become a very fluent and a confident programmer. But let me tell you, you might think, oh, all these things, nuances in Python, does it make sense to know all these nuances? That's what makes you fluent. If I have to speak fluent English, which I don't think I am perfect at it, but I'm trying. Okay, so it's not my native language, but yeah. The more you speak, the more you read, the more you speak, you get fluent in any language, spoken language, right? The same way, the more you read code, the more you practice it. When I mean practice, it doesn't mean you need to write a completely new project. No, try the same thing. So when you try the same thing, you are training, for spoken language, you're training your tongue muscles. With programming, you're training your fingers, your muscles, right? Will be trained. So you say like, they say they think with your fingers. You think with logic, your fingers should flow. That's the fluency that you should get. And that comes with some practice. And yes, you know by now that it does not happen in 1 day or 2 days. Most of these videos I've seen a lot of tutorials that say, I will make you a Pythonista in 2 days. I'll make you become a Pythonista in 10 hours. Good luck. Good luck, I would say. But if you really want to get good at programming, you need more and more practice. You can't learn karate or kung fu in a day. You might know some tricks. Like you see on some videos, I've watched some YouTube shorts where they say, oh, try this stunt. And I've seen some funny memes on them where somebody tries it out and even before he could pull out his shot, he's in heaven with your opponent. So it's the same case. So the more you practice, you get better at it. And it requires a little bit of time, a little bit of dedication. That's about it. Nothing more. Anyone can become a programmer. Programming is like car driving. Anyone can learn car driving, I believe. I tell that to myself. I don't know how to drive a car even now. Just that I'm not spending time on it. But I'm just telling you that with a little bit of time, a little bit of dedication, you can become a fluent programmer. Right? So that's the important thing to keep in mind. So programming is not hard. It only requires a little bit of dedication, a little bit of thought. These are all learning language syntax and idioms. That's what I'm covering at this moment. But as you become fluent, now you realize how to get creative. I know how to speak. I know how to write. Now I need to write something creatively. And that creativity is where we try to integrate the good essences of algorithms, logic, and so on, and try to solve interesting problems. As you do more of problem solving after that, that's the second stage. First stage is language fluency with basic stuff. Second stage, try solving problems. Take a problem statement, try solving it one at a time. Sometimes you take the hard problem first, no problem, move on to the next one, take the easier one, try solving it, then go and try to crack the hard problem. As you try solving more and more problems, your brain gets rewired and you'll start thinking automatically to come out with a solution the moment you look at a problem statement. And that's how you get better at stage 2. And stage 3 is all about figuring out architecture, design patterns, and solving realistic applications, building real projects, right? Or taking on big challenges, trying out lead code stuff. So that's the stage 3 is what I say that makes you even more confident as a developer. It's a long process. When I mean long, I'm not going to say it's going to take years. It takes a few months. So dedicate some time by watching these videos which I'm making. Spend some time, right? Maybe you spend a day, 1 hour or 2 hour a day, or maybe if you think every day is not possible, make it a weekly affair. So just say that okay, every week at this moment, at this point in time, I'm going to just ensure that I'm going to spend about 3 hours to 4 hours or whatever the time that you can afford to learn. The more time you spend, the more faster you learn. That's the whole point. Sometimes some people like to relax and learn in a slow pace, and that's what this training is meant for. This session is meant for. But people who want to learn on speed, yeah, I'm going to make videos for that. But the thing is that if you are new, I would not recommend taking that path. For newbies, take the slow path. Make sure your foundations and fundamentals are strong, and that's what will make you a confident and a fluent developer. All right, then, with that being said, if you really like what I'm doing, if I really think that I'm adding value by the videos I'm making, be sure to hit the like button. And if you're not already subscribed, please subscribe. And if you're not watched my earlier videos, if you just hopped on to my channel and watched this as your first video or any of these sessions, I will be updating the YouTube thumbnails after a while. I know it's confusing. You need to go to the playlist. Just go to my channel, look up the playlist. I think you have the complete playlist of the session from session 1 till now. So we'll be learning much more about functions. So far, in this session, I talked about all the function syntax grammar. That's what I spent on. The next session, I will talk about interesting acrobatics you can do with functions. That will be a very interesting one. There will be a roller coaster for you. Yeah. Hope you enjoyed the ride. So thank you very much. So meet you in the next one.